Hello, today's video we are talking about states of matter. Basically, what is matter? Matter is anything that has mass and occupies space. That one we know of it. But then, how many states of matter are there? Scientifically, there are 5, but today we'll go into 3. The other 2 are the plasma states and the Bose-Einstein states. But we won't talk much about those 2 today. Maybe in another video. So, stay tuned. So the 3 states of matter we'll focus on today is the solid, liquid, and gas states of matter. So let's take them one after the other. So first of all, we like to take the solid. Solids. Naturally, solids are all around us. If you pick anything, it's a solid. And as for solids, they have specific characteristics that classify some certain objects or some certain substances to be solids. A solid has one high density because of its composition actually, and they have a specific amount of volume because they cannot flow or they cannot change shape as much as the other states of matter can, because of that they occupy a specific amount of space, so they therefore have a specific volume. They also are not easily compressed because of their compact nature or the strong intermolecular forces between their molecules. They cannot be easily compressed, and as a result they have very low space for them to be compressed. And fourthly, they cannot flow. They can, when you say something can flow, you say if you necessarily focus on liquids and gases and those things, but because solids have a strong intermolecular force between them, they are not given the free space to move freely and flow and all those things. So now that we've talking about the characteristics of solid, I'm sure you have like a simple sketch of a solid in your mind. Maybe money, cars, mansion, anything is money. Like anything is solid. So there are 3 types of solids, but usually in the secondary stage of education we focus on 2. But when you go to the tertiary, maybe they'll add a 3rd one. This is the crystalline. This one, polycrystalline. Crystalline, polycrystalline, and then we have the amorphous solids. These type of solids are the 3 main types of solids, but then naturally in the secondary stage you really focus on the amorphous and the crystalline. Maybe if you dive deeper you can study the polycrystalline. So what are crystalline solids in the first place? They are substances which are arranged in a definite order. When you say they are arranged in a definite order, it means that their particles are arranged in a specific order. Meaning that if you have a square, they are arranged like that throughout the whole object. They don't vary. That means that they are crystalline. And because they are crystalline, they have specific characteristics such as sharp melting point. They say you have sharp melting point because that is a specific temperature. That's when they break down. That's because they have a uniform. That means they have one point at which they break down, all of them singularly. And they possess characteristic geometric shapes. So if something is crystalline, for example, let's pick diamond. Diamond is formed with a crystalline shape. It has a specific geometric shape because when all of these are arranged uniformly, they form one specific shape, one unique shape, therefore giving them a specific geometric shape. So now we can confidently move on to liquids. What are liquids? As you see, like I said before, liquids are substances which we can easily flow. They have weak when you're saying they have weak, you must compare it to solids. Because if you say you have weak, maybe the examiner might think of a gas and be like, no, solid cannot. The intermolecular force between liquids is not weaker than that of gases, so give them a chance to penalize you. So when you are stating these things, you must be very specific. So liquids have weak intermolecular forces as compared to the intermolecular forces between the particles of solids. When you say like that, they have no chance, or there's no, they are not even given the mandate to penalize you when you are being very specific. And they don't have a specific volume. It's even don't have a specific volume because they don't occupy, they like take up the shape of whatever container they are in, whether it is in a bottle of water or maybe anything, but so like, they occupy that specific amount of volume, and as a result their volume varies even though they contain something like this bottle or the other bottle which I showed you. So as a result, they don't have a definite or specific volume. That's what we can see for liquids. And liquids, their densities, the one we have to talk about it. The density of a liquid is not really fixed because most of the time the liquids, because they don't have a specific volume, density is mass over volume. As because they don't have a specific volume, it means that their density will always be varying. Because once the variables constantly changes, it means that the main component or the main aspect, which is the density, will continue to change. And you see that liquids are compressible. Have you ever bought a drink and you open it and then it's like gas or air has come out? Yeah, that's because it has been carbonated or it has been compressed. When we compress something, we actually force it. So if you think, how come some of the things become like how some of the liquids become solid? Naturally, an experiment was conducted in Germany in 1862. A scientist by the name of forgotten, but then they conducted an experiment where they compressed a liquid. When they compressed it, during compression, the intermolecular forces between the gases, the liquids, were forced to come closer. As a result, the solid components or the liquid started to form crystalline components inside itself. As a result, it will slowly convert into a solid. This shows that when you compress something, you can get it in another form. So let's go back to solids. Let's look at allotropes. Allotropes are substances which are composed of the same thing, but then as a result, but have different physical characteristics as a result of the change in the arrangement. So let's pick a common allotrope that all of us know. Allotrope of carbon 12. So let's pick diamond and graphite. The graphite that you used to write in a pencil is different from the diamond which you buy for your people. So if a man, why wouldn't a husband go to maybe a pencil factory and break graphite and give it to his wife, but he would rather buy a diamond from a jewelry shop and give it to his wife? They're all composed of the same thing, alright, but then there's one thing that changes everything. That is the arrangement. Because graphite is arranged in a uniform structure, it's in a uniform crystalline structure. As a result of their diamonds are arranged in a uniform crystalline structure, and as a result, they have a very specific characteristic, as they are very hard. Because they are hard, they are using cutting tools, they are using mining tools, they are used in jewelry. Because of that, diamond is the least reactive. I don't have any diamond around here, but diamond is one of the least reactive element, like reactive substances in the world. That's why it's made in jewelry. Maybe you see some people's watches made diamonds on it. Because of that, the price of the watch does not decrease because the diamond does not lose its value, because the diamond does not unlike other metals or something that's not corroded, that's not rust. You don't see it wearing off, you don't see it peeling, nothing like that. That's why diamond is very expensive, and the quality of diamond only increases but does not reduce. So let's go back to liquids. So we can see that liquids have surface tension. Surface tension, what is surface tension? I'm sure you learned in Yca that surface tension is the force of that acts at the surface of a liquid that gives it characteristics of skin, that type of thing. It's the reason why insects can stay on top of water and those things. But because of that, not everything has surface tension. This has surface tension. What's the water inside, not the bottle, but the water inside has surface tension. As a result of that, that's why if you look at it carefully, you see that it bends. You can see a bend. That's what you call meniscus. It will naturally bend because it has surface tension. Surface tension, different forces are acting cohesive, adhesive. All those molecular forces are acting on it as a result of the surface tension. So we'd like to talk about gases next. You see, gases are one of the things I would like to go into detail if you pay attention, because gases are complex, relatively complex as compared to solid and liquids and gases and those things. So let's say that a gas is easily compressible because it has either very little or no intermolecular force between us, and then gases have no definite volume. Gases, like liquids, occupy the continuum which they are in, and as a result they don't have a specific volume. Clearly, gases can flow like liquids because of their weak intermolecular forces. They can flow because they move about randomly and in constant motion. Because of that, they can flow. Gases, unlike some other substances, gases can expand. When we say gases can expand, this is as a result of the increase in temperature. You talk about some of the laws. That's when you get a deeper understanding of what I'm talking about. So we're talking about some of the characteristics, but then we're talking about gases not having volume. They can exert pressure, and then they can expand as a result of temperature. So we've mentioned three things: pressure, temperature, volume. So we'll use these three main keywords to form some of the gas laws that are going on. The first gas law is the Boyle's law. Boyle's law is a law that is supposed to govern the study. Like, it explains how gases act as a result of, in certain conditions, how they act. So Boyle's law. Boyle's law says that at constant temperature, the given mass of a volume, the given volume of a fixed mass of a gas, the given volume of a fixed mass of a gas is inversely proportional to the pressure of the gas. This means that P or V is equal to K over V. Yes, P is equal to K over V, or V is equal to K over P. Whichever one, you still get the same thing. So it means that when there's an increase in pressure, so use the kinetic law to explain it. So listen carefully. If they set a constant temperature, meaning that if the temperature is the same, and the pressure, and there's an increase in pressure, when there's an increase in pressure, it means that the gases will expand, so they'll occupy a larger volume. So mean that increase in pressure has results in an increase volume. That's what it means. Secondly, we like to talk about Charles' law. Charles' law Charles' law states that at constant pressure, the fixed volume from mass of gas is directly proportional to its temperature. It's proportional to the gas at its absolute temperature. Let's put it that way so that we on the safer side. Meaning that we have V is equal to KT. Meaning that if we make K the subject or K which is the constant the subject, we have V over T. This is simply using the kinetic theory of gases, we can explain it or further elaborate that when there's an increase in temperature, meaning that there will be an increase in volume. Because when you increase the temperature, you increase the kinetic energy between the molecules, causing them to move about faster, building up more pressure. When you build up more pressure, it increases the volume of the gas. Let's take a particular example. Have you ever had Sobolo in a bottle or Sobolo in a bottle? If you keep it there for 2 days, you realize that the bottle has expanded because the Sobolo naturally ferments. It releases gas. Because it releases gas, it will increase the pressure. Because it has increased the pressure in the bottle, it will force the bottle to expand. Because that's for the bottle to expand. The volume has therefore increased. This means that Charles' law is at work. So all these things, they are particular explanations in real life. Let's talk about Graham's law of diffusion. What's diffusion in the first place? Diffusion refers to the movement of gases from a region of higher concentration to a region of lower concentration till it has reached uniform distribution. Meaning that if I have sprayed perfume at this corner of the room, I should be able to smell it within some few minutes at this corner of the room, the other opposite corner of the room. Meaning that the gases will move about till it has met equilibrium. Equilibrium in the sense that the equal amounts of gas here will be here and over here and be here and be here. So the whole room will be filled with an equal amount of gases. So now that we know what diffusion is, let's talk about Graham's law of diffusion. Scientists called Graham something propounded a law that the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. This means that the rate, or let's say the density of it, is